Okay, so picking up where we left off, today we're going to talk about this, okay? We already know that Boolean is related to what we've been talking about, that it is a two-state. Okay? A 0 or a 1, or the traditional way we think of Boolean is true and false. Okay? But I'm going to say let's apply this word, this concept of a Boolean system to logic. Boolean logic. Okay? So forget computer science and math and all that. If I said to you Boolean logic, but you knew Boolean meant one or the other, what kind of words would you use to describe that?
Yes or no.
Yes or no? Still true or false, right? Did you guys ever play a question game where you can find out the answer to something by just answering true-false questions?
Yeah,
Like 21 questions, right? Where you basically ask 21 true-false questions to figure something out. That's essentially computer heuristics, and there's been some studies based on it that if you create enough true-false questions, you can essentially figure out the answer to most puzzles. Because if you ask the right questions and get a true-false answer, you can eventually narrow down to the thing you're actually looking for. So that true-state system of logic can be applied to the real world. Okay? So let's apply it to math. So the math you guys know is different than the math we're describing. Okay? This is the math you know. Okay? The math you know involves digits 0 through 9, and you can combine those to create numbers. Right? These are your digits. Okay? It's a what's called base 10 digit system. They're 10 digits. What basic math operations do you know? Like how can you... Okay, addition, subtraction, multiplication, division. Yeah. Okay, you're right. Those are your basic things. But we've talked about this a little bit before. Do you really need all those? Okay. Because we could keep going. We could use powers. We could use logarithms, etc. We could expand that math like your actual math training has. But really, let's just use multiplication. Multiplication is just repetitive addition, right? Subtraction is really also addition, but as long as we make things negative. So really what stands out here is we need that addition thing, and we need those digits. And based on that, you can do the math you know. All right, now, let's talk Boolean math. What do we need for digits? Right, we just need the two. 0 and 1. Okay, that's going to be easier. And here's where it gets slightly different. We don't even need addition. We're going to, for Boolean, just like the question game, we're going to use 3 different basic math operations. The first one is the easiest one. I'm just going to say the word not. So if something's not true, what is it? So if something's not true, what is it? If something's not false, what is it? If something's not 1, what is it? If something's not 0, what is it? You know what not means now? It's pretty simple, isn't it? So not just inverts things. Okay? So sometimes not can be just called an inverter. And in a two-state system, that's super easy. Because if it's not 0, it's 1. If it's not 1, it's 0. Beautiful. Okay, now, here's one I know you've seen before. And. Okay, go back to the system you know. What's 1 plus 1? 2. Let's move over to this system. What's 1 and 1? Keep in mind, there's only one answer you can give me. Well, there's 2 answers you can give me. It's a two-state system. What's 1 and 1? What's 1 and 0? Ah, we're confused. What's 0 and 0? Okay, how many different combinations can we have? 1 and 1, 0 and 0, 1 and 0, 0 and 1. But that's really kind of the same thing, right? That's like saying what's 2 plus 1 and what's 1 plus 2. Okay, so we got to work on that one. And I'm going to give you the final one. What's 1 or 1? What's 1 or 0? Ah, so we're a little confused. Okay, so this is the system we're talking about. Okay, so let's answer that question. Let's write out the possibilities. And I'm going to use a symbol rather than keep writing out the word. Well, maybe I'll write the word at first. Okay, so not 0 equals not 1 equals. Okay, so you've mastered that one. But that's a lot of writing. So the symbol that Boolean Algebra, I'm not going to use that word, uses to describe this varies instructor to instructor. I'm going to give you the way I was taught it, and it looks like this. What you would call in math the prime symbol. Right. That means not 0. In some, they'll use an overline. Okay? In some, they'll use that symbol. Some use that, I don't even know how to draw this one. Some of you guys, I think, do it in math properly. It looks kind of, I think, like that. Does that one look familiar to you? Okay, so never mind. Don't worry about it. I'm going to actually reduce this just down to this one. That's the one I'm going to use. You may encounter that one. And actually, as you look through the exams, you might see it on the exams as well. Okay? All right, so we got not down. All right, so now let's go with and. 1 and 1 equals. Okay? 0 and 0 equals. 1 and 0 equals. And 0 and 1 equals. That's all the combinations we could possibly do using just our two states. Let's talk about the answers. Okay, what do you think? You got a 50-50 shot of getting it right. It's either a 1 or a 0. What's this one going to be? Okay, you're right. Here's how you would know if you think back to the way you use the word and in coding. Okay, let's say you had two variables, x and y. And you wrote an if statement that says, if x equals 5 and y equals 5, do something. And then in the line before, you said x equals 5, and then you said y equals 5. Would the if statement execute? Okay, hang on. Let me write it. Explaining it probably isn't good enough. Let's say I had this code. And the and symbol, as we know in coding, is this. Would the whatever code is in here execute? Okay. Would this inside part of the if statement run? Would it run now? Okay. So it runs when this is true and this is true. But what does and really mean? Both have to be true. If one of them is false or both of them are false, it doesn't run, right? Okay, you understand that from coding? Why is this a 1? Both are 1. So we can think of 1 as true. What's this one going to be? James is right. Why, James? Right. It's like this. If I had this, 1, 10, and 15, what are they both? This is false. This is false. This is 0. This is 0. So that generates a 0. What does this generate?
0.
Right. And this one? 0. Right. Okay. Let's hold that for a second. Skip past this. Now that you know how it relates to, let's do this. Okay, what are the answers going to be? What's this one going to be? 1 or 1 is? What do you think? That's right. 0 or 0? Right? 0 or 1? Right. And? Okay. So let's compare. Okay, notice the difference here versus here. It's a two-state system. Okay, let's write it out in a different way. Instead of writing the word and, the way it's done in Boolean algebra again varies. Okay? But with and, they essentially equate it to what we call multiplication in algebra. So how would I multiply 2 times 4 in algebra? In algebra, the algebra you're knowing now, I wouldn't put the x there anymore. That you're beyond that. What would you do? Or actually, let's not say 2 and 4. Let's say 2 and x. How would I multiply those two things together? How would I show that? Seriously? You'd write 2x. Or you could write that. That's still often allowed. Or yes, you could put brackets. Okay? But the simplest way would be just that, right? That's the simplest way. Okay? You're not going to use this symbol anymore, I would hope, in writing multiplication in algebra class, because it's super confusing. Okay? You might do this if you feel like doing that in algebra class. You might do this in algebra class, but you're probably just going to write it that way. And works the same way. And becomes multiplication. So this is not an option. These are your 3 options here. Write it beside each other, use brackets, use a dot. So let's do it that way. 1 and 1. 0 and 0. Okay? All right, we get the idea. That's and. I'm not going to write the answers. We already did that. With or, it uses this symbol. Not with a circle around it. That's probably confusing, actually, so let me remove the circle. It uses the symbol that we use for multiplication. This is where you're going to get confused. Because that's what it means. 1 or 1 is 1. But you see that and you think, oh, it's 1 plus 1 equals 1. What? That's crazy. But that's what we mean. Okay, so let me test you a little bit. Okay, don't use plus. Use the words you need. You are only allowed 3 words. And or not. So here's what I want you to say. Read me what that says. No. Just read me what it says. Don't try and evaluate it. Read it to me in words. Not 1 or 0 and 1. Not 1 or 0 and 1. Let's write it down. This says not 1. And actually, let's take the word 1 out of it. And let's translate it to the two-state system. And use not true or false and true. That's essentially what it means. Not true or false and true. Now, you know in regular math, there's an order to things. Multiplication is done before addition and subtraction, et cetera, et cetera. There's an order to this, a precedence order. Okay? Which do you think has the highest precedence? Like, what should I do out of these three things, or, and not? Which one should I do first? Not. You're right. Okay? So the not is of the highest precedence. Okay? What do you think is next? None of them are even, just so you know. Someone said it. Yeah, and actually is correct. And the easiest way I'd say you can remember that is it's the same as it would be in regular math. Because we're using multiplication to represent and, so multiplication comes first. So then and is next, and then or, unless you use brackets. Okay, so let's evaluate this thing. What should I do first? The not. So not that, please. So, okay, let's rewrite it. 0 or 0 and 1. What do I do next? And. So let's and these two things. What's 0 and 1? What's 0 or 0? You've just evaluated that equation in Boolean algebra. That's how it works. Okay? This is algebra using a two-state system. Okay, let's take a look at what the IB actually says you need to learn for this before we get into that. What the IB says you need to learn is define the Boolean operators and, or, not. A couple new ones coming. NAND, NOR, and my favorite, XOR, or the cool kids call it XOR. Okay? We're going to learn those in a minute. We'll get to those. Okay? So and, or, not, NAND, NOR, XOR. By the way, NAND, NOR, XOR, fun to say, but also are variations on the first three. Okay? Construct truth tables using the above operators. We haven't learned that yet. I'm going to get to that. Okay? For example, Maria won't go to school if it's cold and raining or she has not done her homework. So you've been given a question like this. Maria won't go to school if it's cold or raining or she has not done her homework. And then they'll say to you, Maria did her homework, but it's raining. Will she go to school? See what I mean? Okay, so it says no more than 3 inputs will be used. We'll talk about that. Construct a logic diagram. Oh, what's that? We're going to figure that out and what that means. So that's coming up in the curriculum as to what this stuff means. Because the logic diagram, have any of you in here taken electronics with Mr. Yakumovsky? Never? Or studied? Or actually it's often covered in physics class as well. Have any of you ever seen this symbol in electronics class or physics class? It looks kind of like a plug, but it's not. This symbol is what's called a gate, and specifically, it's the AND gate. Yep. So, if I do this, what comes out this side? Right, a 1. If I do this, what comes out? Right. The same way this gate is the NOT gate. Notice it only has 1 input and 1 output. So if I put a 0 in, 1 comes out. If I put a 1 in, 0 comes out. It inverts it. The OR gate is the most fun one to draw. I always say it looks like a rocket ship. This is the OR gate. Watch this. See that equation right there? Okay. Not 1. Okay. Now I have to combine these two using an AND gate. Okay. And then I combine the result of this AND gate with an OR gate. I give that to a electrician, they build me a circuit that executes that logic, which executes this sentence, which turns the real world into electronic two-state system worlds. I hope you're starting to see it all start to piece together now, okay? Because watch, this is me sending a 1 in here. This is me sending a 0 and a 1 in here. Because watch, 1 gets knotted, it comes out a 0, which is exactly what we did right there. And takes these two things together, 0 and 1, and a 0 comes out, which is exactly what we did right there to turn that. Then these two zeros combine with OR to generate a 0 coming out. Okay? Finally, I think this is about all we'll have time for today, is something called a truth table. A truth table is another way to look at it. Okay? Now, you know what a table is, and you know what the word truth is, but how does the word truth relate to our system? Something is either true or not true or false. Okay? If any of you took theory of knowledge with me, there's actually a law of logic that relates to that, called the law of contradiction or the law of excluded middle. You don't need to worry about that. That's a philosophy thing. But it basically says the philosophy of the universe is such that this is a basic law of logic. All philosophy is based on this. We assume this law, which is, if I made a category over here called pencils, and I made a category over here called not pencils, I can divide the universe. And everything in the universe is either going to go here or here, and there will be nothing in between. It's either something cannot be a pencil and not a pencil at the same time. What's that? Well, that's fine. You can say, but it can't be mechanical pencils and not mechanical pencils at the same time. Now you're using multi-categories, right? I'm saying in terms of this law, it's either, and that's what I mean by, okay, so let's pull back. We're going to have and, we're going to have or. Don't question me, yeah. All right. Okay, so let's make a table here. So I'm going to say, I'm going to combine a 0 and a 0. What's the and of that? What's the or of that? Okay, what would be the next sequence? I'm going to say it's this one. And then I'm going to say the next sequence after that is this, and the next sequence after that is that. Help me fill out the rest of the table. Okay, hang on, let me just draw the grid lines. What goes here? Come on, you guys. What goes here? 0 and 1. What goes here? 0 or 1. What goes here? What goes here? What goes here? What goes here? Okay? You've just created a basic truth table of the basic functions of Boolean algebra. But I also like to point out the way I wrote those numbers over here. Anyone notice anything about the way I wrote them? They're binary counting there. That's basic binary counting right there. Right? 0, 1, 2, 3. 0, 1, 2, 3, right? If we go back to that table, so I did it that way. Okay? So in regular system, this is 0, 1, 2, 3. Okay? That's a truth table. Essentially that kind of stuff. It's all going to come together now. We're going to have to spend way more practice on this, but now you're going to start to see how this all comes together.